3.4c is on correlation versus causation. So we've already talked about the correlation coefficient, and now we're going to talk about something called causation. So correlation is when two variables have a relationship to each other. So if it's positive, as x increases, y increases. If it's negative, as one of them decreases, the other increases. Okay, so that's our correlation. Causation is a cause and effect relationship. So causation is saying that not only is there a relationship, but one of these increasing is causing the other to increase, or one of these decreasing is causing the other to increase. Okay, so a causation is that cause and effect. So one of them is causing the other to occur. If two variables have a strong correlation, it is tempting to conclude that one variable causes the other to occur, but correlation does not mean causation. So that means we could have a really strong correlation coefficient. Okay, our correlation coefficient could be like 0.97, or our correlation coefficient could be equal to 1. But if the correlation is that strong, it still does not mean that there's causation. It still does not mean that one event is directly causing the other. So here's an example for a little cartoon from the family circus. It says, I wish they didn't turn the seatbelt sign on so much. Every time they do, it gets bumpy. So Billy thinks that when they turn the seatbelt sign on, that causes it to get bumpy. But that's not the relationship, right? So there's a correlation there, but his causation statement's a little off. So we're going to look at a couple examples. Example 1, the correlation of coefficient between sodium content and number of calories for fast food items is R equals 0.81. Okay, so our correlation coefficient is 0.81, which isn't really close to 1, but isn't really far away. So we could say this is strong or kind of strong. Okay, strong or vaguely strong, but not really strong. So looking at this means that items with higher sodium content, right? So items with higher sodium content tend to have a higher number of calories. Okay, so our question is this correlation or causation? Well, we can see that there's a correlation, right? We can see that there's a correlation because we have a fairly strong correlation coefficient. So the question is the high sodium causing the high calories? It's not, okay? So this is correlation, but not causation. And the reason is sodium has no calories. Sodium has no calories. And since sodium has no calories, it cannot be the reason that the calories are going up, right? Since sodium doesn't have calories, it can't cause there to be more calories in the food. So it's common. So if you think about like French fries or potato chips, those tend to have more calories, but it's not because of the sodium, it's just because of the type of food it is. So this is an example of where we have a very strong correlation, but it's still not that causation. All right, so sodium has no calories, so it cannot cause food to have a higher number of calories. Let's look at another example. What type of correlation would you predict between shoe size and reading ability for 5 to 18-year-olds? So looking at this, as our shoe size is increasing, our reading score is also increasing. Okay, so there appears to be a correlation, right? There appears to be a correlation between these things. So we have to ask ourselves, is one causing the other? So do we think that shoe size causes children to read better? So if your feet kept growing, would you keep reading at better and better levels? Hopefully your answer is no, right? Just because your feet grow, that doesn't mean you're going to get better at reading. So this is correlation, but not causation. We're going to look at two last examples. For the given situations, we want to answer, is the correlation positive? So they're both increasing. Negative, one is increasing, the other's decreasing, or is there no relationship? So it's totally random. And B, we want to answer, is the causation statement true or false? So is one actually causing the other? So looking at problem number 1, the number of tardies you get at school versus the shorter amount of time to get to class. So our causation statement says, therefore you get more tardies when you have less time to get to class. So for letter A, is this positive, negative, or none? Well, the tardies are increasing and the time you get to class is decreasing. So since one is increasing and the other is decreasing, this would be a negative relationship. This would be a negative correlation. Letter B, is it true? Is it true or false? Will you get more tardies if you have less time to get to class? Well, to a certain extent it is, right? If you think about our school is pretty gigantic. So if you had a class in the 1300 wing right after a class in the 2600 wing, if you only had a minute to get to that class, you'd probably be tardy a lot. So we could say that this is true to a certain extent. You get more tardies when you have less time to get to class. One more, number 2 says the more hot chocolate consumed versus the increased number of people who go sledding. So causation statement. Therefore, drinking more hot chocolate makes people go sledding. Well, we're drinking more hot chocolate and more people are going sledding, so they're both increasing, which means this is a positive correlation since they're both increasing. Is this true though? Does drinking hot chocolate make you go sledding? Every time you drink hot chocolate, do you have to go sledding? Hopefully your answer is no. This is a false causation statement. Drinking hot chocolate does not cause people to go sledding. So this is our correlation and causation. And again, that main thing you want to take away is that even though they're correlated, that does not mean that one of these factors causes the other to occur.